We launched SecureBuild last week. Hopefully you saw it. And I want to spend the next little bit talking about like what SecureBuild is, why we created it, how it works, and how you can actually use it with Replicated today. So first, just a recap, like SecureBuild, we launched it last week. It is in a distribution platform where we're creating secure builds of OCI images that you can use, aiming for zero CVE distribution of open source container images, multi-architecture, both ARM and AMD64, packaged in minimal distro-less containers, creating SBOMs for every package that we're doing, scanning and being very transparent about any CVEs that are in them that we're detecting. We rebuild everything from source in here, and then we rebuild when any dependency is updated or changes. And that's how we're able to maintain minimal CVEs in these images. And like I said, we're going to talk about how that actually all works. One of the things that sets SecureBuild apart from other folks doing the same thing is that we're partnering with open source projects. So instead of just taking open source projects and making secure distributions and secure builds of them, we are working with the folks who are maintaining these open source projects so that they can validate the images, making sure that they actually do work the way that we claim that they do, and they're supportable. We ask for embargo access for vulnerabilities discovered in the project themselves. So this isn't like obviously dependencies that you need to update, but if you discover a CVE or a vulnerability in the project, we do want to be able to make sure we can get that image out there pretty quickly. And then, the goal is really just to create open source that's more sustainable. Well-funded projects have the bandwidth and can care about security, and it provides incentives for ongoing maintenance of these open source projects. So a lot of the projects that we have, not all of them, but a lot of them are partners that we've partnered with to create the secure builds. If you have open source, that you want to talk to us about, like, we'd love to hear and love to work with you on it too. So why now? To kind of set up the problem a little bit, we've obviously been dealing with security, we've been dealing with vulnerabilities and patches, but why did Replicated decide to build this today? I think a good way to kind of describe this is to look at a Docker file. So this is a Docker file for a kind of a typical enterprise quality Java application. This is, for a microservice, this is one jar file. This is an entire application. If you've written Java applications, probably this looks familiar. If you haven't written Java applications, it still probably looks pretty familiar because Docker files kind of work the same way, multi-stage. Here's like the from, here's all the dependencies I pull in, I compile it, then I create the application, removing anything that I don't need. If you went to ChatGPT and told it you need a Docker file for a Java application, you're going to get something not that different from this. So it doesn't look that complex. Where's the problem coming from? Well, you take this Docker file and you run it through the dependency graph. What's included in the Docker image we're shipping to a customer? And it kind of looks like this. At the top, you see we have one final image that we're actually distributing, but in it we have the Debian base, OS and everything that it brought in, like glibc and OpenSSL and apt and things like this. That any of those could have vulnerabilities. The JRE, the runtime for this Java application, includes things that you didn't depend on. TZ data, you never asked for time zone information inside your application, but it's like a dependency of your application that's getting pulled in. Obviously, the third column is the jar file itself for your application. Those are things that you generally do bring in, but some of those have their own dependency graphs, and then the environment. So you can see like the point here is really a relatively simple microservice Java application does turn into a container image that has a whole lot of stuff in it. So how do you solve this, right? Like this is just your app container, and you think it's just your jar file, look at the code you're writing. But when the example I brought up earlier was TZ data, let's say that had a vulnerability. So how do you patch that? First, you have to know that there's a vulnerability, that it was discovered, and then there was a patch. But you're not consuming TZ data like JRE is, the Java runtime. So you need to go get a build of the Java runtime that incorporated that patch for TZ data. But you're not even consuming that. You're using Adoptium or some other Java runtime. So you have to actually wait for that to adopt that and pull it in. And then you rebuild your application. So you have to kind of wait along the supply chain for all these various components to get updated in order for you to be able to ship the vulnerability-free version in your application. You have an SLA with your customer, right? Your customer is asking you, you have to commit to, days to deliver anything that's a high or a critical patch into their environment. But not all these open source projects have an SLA. And then there's multiple streams of these. And so it really does become a challenge. That sounds difficult, but it's actually even more difficult. So this graph here, which shows what this Docker image looks like, let's zoom out on what an actual enterprise application that you might be distributing through replicated actually looks like. So we zoom out and you have your jar file here, right? This is the one microservice with all of its dependency graph. But then it's, maybe you have microservices. So you have 4 different microservices that each have their own separate dependency graphs. Sure, there's a lot of overlap between them, but there's differences between them. And then you start bringing in all your open source components. You have Postgres and Nginx, and you have, the NVIDIA GPU operator, whatever all these components are, and they have their own dependency graphs. And this just becomes way too much to manage. And it's not even a build time problem to manage. As soon as you deliver an application or an image into your customer's environment, you deliver an image and that starts a clock. They scan it before they run it in their production environment. And then tomorrow, they're going to update the image scanner, the image definition, and scan it again. The next day, they're going to do the same. And as time goes by, more and more of those vulnerabilities are going to be discovered in different components that exist in the application. You delivered an image one time, but the battle you're fighting is the vulnerability definitions are getting updated constantly, and they're going against that static image that you actually delivered. And it's good to point out here too that most of the vulnerabilities, they're not actually discovered in the code you're writing. They're actually discovered in the dependency tree of everything that goes up. And it's not even direct dependencies. It's often like something deeper and deeper into that dependency tree. And there's just so many CVEs. It's impossible to keep up with manually. NIST shows a graph where there was 40,000 publicly disclosed CVEs last year. That's a lot. Sure, like they're in different languages. They're not all in your application. They're not all affecting you, hopefully. But that's a lot. Extrapolating this to the same continued 30% growth year over year, you just end up with, in a few years, it's already unmanageable. It's just going to keep growing, though. Like there's no expectation that the number of CVEs is going to like flatline or level out.
Yeah, let me jump in here, Mark. I think this graph and the one right before it are maybe the most important thing, right? Like when we started Replicated, you're talking about like 8,000 CVEs a year. Now we're at 40,000. And so this is why, and then if you think about the number of enterprises who are scanning images regularly and have the automation and the tooling set up around this, there's tons of these scanning vendors out there. There's open source tooling. So this is why this has become such an important thing to do. Enterprises have requirements around it. Some governments have, mandates around it. So it really is a kind of like hair on fire problem now for a lot of our customers. And, we've heard it and we've made some little cute videos about it, but people are really playing CVE whack-a-mole with their applications, with their dependencies. And so, when I saw this graph, I was like, oh, this is why, right? It's just because it's become so noisy and there's so much work to do in order to close out these CVEs, which most of your end customers now expect you to do at a very quick pace. And again, we just expect it to only get worse, right? With all of the AI generated code that's going out there, AI generated fixes, AI generated CVE discovery, it's just going to be a larger and larger problem in the future. And so that's why we said we need to do this now, right? We know that our customers are facing these challenges and we think we can help provide a solution for it.
Yep. So moving on, we want to talk about, we built SecureBuild. I kind of described what it was up front. How does SecureBuild actually solve the problem that we just described? To start, we rebuild everything from source. So in that example of that entire dependency tree for a Java application, we build each of those packages separately from source. We know the repo where TZ data is, or OpenSSL, or glibc. We're monitoring that repo. We're building and maintaining multi-architecture packages for all of those different dependencies that you actually have. And then we track the dependencies of everything. So when we build any component, we know that it's dependent on glibc or libssl or OpenLDAP, whatever the dependencies are. We track that entire dependency tree and we have it. So when a CVE is disclosed and fixed in anything, we detect that there's a new version of that package available. We rebuild it. on our trusted hardware. So it's in a really clean, reproducible, ephemeral environment. We rebuild that. So you get a CVE-free version of that component. And now we know the dependency tree all the way down to the final layer, which might be like Postgres or Redis or Timescale or something like this. And we rebuild everything that depends on that, and then everything that depends on that, and everything that depends on that, until the final thing that we get is an image that you want to run that no longer has that vulnerability in it. On top of that, we scan every day. We scan every CVE, or sorry, every OCI image that we actually have, and publish the results. So, the goal is CVE free and have no CVEs. I described the way it works. Obviously, there's a little bit of a time between when that vulnerability is disclosed and fixed, and we build the entire tree. We commit to right now a 6-day SLA for resolving critical vulnerabilities in any image, but right now we're able to massively overachieve on that, and our goal is to continue to drive that SLA down so that we want to get to the place where we're measuring it and committing to measuring it in hours instead of days, that we're actually fixing critical vulnerabilities. But you can see we have the canonical version of the image. So when we take an image like a database, we know the we know that the Docker Hub version that you might be using, and we scan both of those and we compare them, and we show you which vulnerabilities were removed because we rebuilt the image. In addition, we publish a software bill of materials for every image. So this just lists everything that's inside there and where it came from. And this is an example here of, I think this is TimescaleDB. We show it, so you actually get to see all the components that were in it. You get to see all the licenses for all those images, all those components too, which is something else that you are often asked for. And then on the right, you can see in that SBOM, and we do make the raw SPDX format SBOM available to download, but you can see where they came from. So in this example, all of the components were built from SecureBuild, but we're really transparent. If there's something that we're pulling in externally, you'll see that in that SBOM. Thinking about how we do this, the final step then is we package this entire thing up in a OCI image. That's just a typical Docker run command, right? So you can just run this in your Kubernetes application, Docker, anything you want. We put it in a distro-less container, removing anything that's unnecessary. So these are production quality, production grade hardened images. The goal there is really to reduce the surface area. You don't want to have components and libraries and other things, packages in there that you don't need, because that's just going to increase the times that you need to update this package. So making it distro-less, removing all unnecessary packages doesn't remove the problem. It just reduces the frequency that you need to that you're going to have to receive updates, because there's less things that are going to get updated, which in turn allows you to remediate quicker because you're shipping less frequently into the enterprise customer. Our solution is really designed to be drop-in replacements for these open source images. So here, on the left is a very simplified version of a stateful set for Postgres that you might be running. On the right, you can see we just changed the image to CVE0.io Postgres 17. We have a lot of automation and testing in place that makes sure that the images that we're delivering are drop-in replacements. They have the same entry point, the same args, the same command, the same environment variables. Our goal is to make these images literally work identical to the ones that you're used to using right now. So you don't have to think about how to adopt the image. It's literally just change the image name to the CVE0 version. And CVE0.io is the registry behind SecureBuild.com. I want to give a little example here that happened last week. So we launched SecureBuild last week, and a couple of days before we launched it, there was a CVE disclosed in Go. And it was a 7.5. It wasn't a low one. It was actually causing too high CVEs to show up on anything that was built with that version of Go. At the time, last week, 124.3 was the current version of Go, and it affected 124.3 and all earlier versions. So basically, any software built in Go now had too high vulnerabilities, even though 2 days before they weren't reporting anything. Kind of the classic example. The Go team, it was a responsibly disclosed vulnerability. The Go team shipped 124.4 with a patch, but it's a build time problem, right? Not a runtime problem. So you can't swap that into your container and actually get the vulnerability fixed. You actually need to rebuild your application using a newer version of the Go compiler. So we have a package for Go 124.3 at the time. It auto-updated to 124.4, which then caused the package trees to rebuild. And so we have like all of those images temporarily showed two high vulnerabilities, but our tree was rebuilt and then they were repushed with the same tags. And now they had no, like those two high vulnerabilities were removed. A couple of projects in our that our partners had those vulnerabilities in them. Open source, they will get to them. They will fix those, but we were able to remediate them really, really quickly because that's what we're doing is we're taking their Go mod, their package, updating the version of Go, recompiling it and republishing it. And so we were able to get those vulnerabilities out before we launched. The catalog today, we launched with, I think we have added a few more since this screenshot was taken. But we've added some that are partners. They have like the little green tag on them, and some that aren't. They're just open source components that either we're using or that we have somebody who is interested in using. We have all of these in our catalog, again, designed to be drop-in replacements for the upstream version. You can see how often we're rebuilding them, the number of vulnerabilities we fixed. If there's something on here, there's clearly, there's a lot more images out there. We're happy to get them all added in. We're working really hard to grow this catalog kind of as quickly as we can. We want to make sure that they are good. There's a couple images here that I want to point out in addition to the partner ones. We have some language images, Node.js, Python, and Adoptium. That's actually they're all the three on the right-hand column. These are images that you probably don't just run in your customer environment. You might run TimescaleDB or Postgres, but the Adoptium, Python, and Node.js are just images that you'll generally build your application on in your environment. So we're making those available as base images for different languages and runtimes, and we're going to continue to add those in with Go and other languages here as we go. The other thing that you can do when you're using SecureBuild images is you can redistribute them from replicated. We are not going to charge you per customer to relicense and redistribute each image that you have. If you have access to an image on SecureBuild and you're shipping your application on replicated, you can redistribute that image to your replicated customers. You basically do it the same way you would, if you're familiar with replicated, the same way you would distribute any other external registry. So you can just go to the vendor portal, add in CVE zero.io. It will be able to proxy the SecureBuild images through your Helm chart, through your application on replicated. And then that makes it compatible with custom domains that you have, it compatible with air gap, compatible with everything. So if you're using, again, like I'll use Timescale as an example. If you're using Timescale in your application, you can get Timescale on SecureBuild and then proxy it and then distribute it to your customers through replicated for Helm installs, for embedded cluster installs, for anything. There's the last part here is that it's more than just open source. Most, like all of our applications, also have images that we're building, and we can help with that too. So I mentioned earlier that we have those three language images for Java, for Python, and for Node. You can use those. You can just from cv0.io/node22 or whatever version you want and build your entire image that way, push it, do whatever you want to, distribute that image through replicated. Obviously, you need to subscribe and know when we update that version of Node in order to rebuild your own image. So, we can show you how to do that and trigger that pipeline. Alternatively, we can also build the images. It takes a little more work on our part, but we're happy to work with you. The same way we're building our entire tree, we can pull your package in and actually build your OCI image. So when a vulnerability is disclosed in something that you depend on, or that the thing that you depend on depends on whatever, your package, your OCI image can totally get rebuilt. We are looking to get started here. Use any of the base language images as your base image today. It's really easy. If you're a replicated customer, pick one of them, let us know. We'll give it to you for free so that you can actually use that image now. So Node, Python, or Java. If there's a different language you need or a different runtime, let us know. And then try out any of the open source components. If there's a database, if there's something else in here that's available in the catalog, try it out as a drop-in replacement. The partner ones, we're working with the partners to validate that they are true drop-in replacements and they function exactly the way they do. But again, we have a lot of automation in place that's really making sure that this actually does work. I think that's it.
Mark, let me just reiterate that. So we are giving every replicated customer a free subscription to one of these language images, correct?
Yes, exactly. The ones right now, they're the ones on the right, but we'll continue to add more.
So that's kind of, the way these are priced today, that's basically a $6,000 to $12,000 a year sort of like freebie for every replicated customer to be able to build on a zero CVE base image for their kind of internal application. And so we're doing that, one, is a way to just get everyone started with, SecureBuild, but two, because we think, for a lot of our customers, that might be the only one they need, right? If you're just shipping, a Node app or a Python app and you have, requirements for external dependencies, maybe that's all you're going to need. And you can, now use SecureBuild to make sure you're delivering a zero CVE image to your customers and full application, hopefully.
And it's really easy. Honestly, it's literally just if you're like from node 18, it's just changing that Docker file command and that's it. You obviously need credentials and a service account token in order to pull it, but like there's nothing else in the Docker file or your application you should have to change to make this work.
Yeah, and that's going to be for every subscription. That if you're a builder's plan, business plan, enterprise plan, you're going to be able to pick, and we're going to add the Go, we're going to add the Rust, we're going to add whatever other languages
Mhm.
folks need. So we want to have full coverage of the language kind of images. But I think this is a really valuable thing for our customers and something that we're excited to be able to do in order to start to get everyone adopting this and using it and getting value from this without necessarily having to go subscribe to, another service. Obviously, if you need these other images, you can work with us. If you just need one, you can just go ahead and click through and buy it on the website. I mean, that it works today. So if you just want to subscribe to, Weaviate or to, Nginx, you could do that and get the subscription. If you want to subscribe to a couple, if you're going to like, hey, we need, 3 or 5 or 10, just, talk to us, talk to your sales rep. We're going to be able to give you better pricing than, is on the site for most of those. We do expect, if you're kind of doing, 5, 10 images, we should be able to get them to you for about 5K a year, which I think is very, very competitive in terms of what's out there in the market. And then you're going to get a free one as well. So hopefully everyone sees the value there and, really starts to partner with us and get these images, out in production with your customers.